computer forensics, and we're down to the third class. So we're going to talk about Mod 3, which is hardware. These projects that are due tonight, I'm going to extend them next week. Don't worry if you didn't get them due, because I had trouble getting my machine running, and students are having trouble too. So, and I'll demonstrate how to F200 later. And I've improved the instructions for F60. I now include the M1 instructions, which were not there. I read them just a couple days ago. And so my M1 machine is running better than it was last week. I had trouble with my Windows machine on this M1. So let's start with the Mod 3 hardware stuff, which is in Canvas. And that is here. Right here. And here. All right. So the hard disk drive is, as I said, the main repository of data you want for computer forensics. There's some interesting information in the RAM, but most of everything is stored on the hard disk drive, or these days an SSD. Older machines used to use this system called SCSI, Small Computer System Interface, and there may be still some old devices like this, but home computers, very few people are still using SCSI, just older-fashioned machines that companies are. Now IDE was the one that came after that, and up until maybe 6 years ago, a lot of machines used this IDE stuff with these two parallel sets of pins with a gap towards one side. This would have these flat ribbon cables to connect your hard drive and any other components in your computer to it. So that's one way to do it, but mostly what they're all using now is SATA, serial ATA, which has a much smaller connector with a little notch in one end and looks like 6 or 8 pins in there. These are faster and very common. You can use them for internal drives, and you can have an external port to plug in external drives with SATA. And it's a rival to, say, USB, USB-C, and so on. But anyway, SATA is what they use for internal drives. It's much faster. And you see the connectors here. So once you've got a hard drive and you want to make a copy of it, forensic examiners want to make a complete bit-for-bit copy of a hard drive. They need every bit on the drive, not just the files that are currently in use. So normal backup would just copy the files that are currently in use. But a forensic examiner wants every bit so they can recover deleted files. And there's two ways to do that. A clone is where you make a 100% copy of the drive on another drive, so you can replace that drive with this one and boot from it. And that's what companies typically do. If you have a company with like desks with laptops with machines on the desks, they typically, if they get infected or they stop working, they don't bother to fix them. They just have a new hard drive with the operating system and all the apps you need installed on it, and they just swap it in. That's the fastest way to make an ordinary desktop machine work again for companies. So they just clone a lot of these drives all the same and have them just ready to go. Now, however, another thing a forensic examiner often wants is they do not want an exact drive ready to boot. What they want is an image file that will contain all the data from the drive, because they don't intend to boot from that drive. They intend to analyze that drive. This is the most common situation. You make an image file. And that's what you're going to analyze with a tool like Autopsy, which is what we're going to do here. So it still contains every bit on the hard drive. It's just stored in a file, so you can store it on another larger storage drive to play with it and run software on it and such. And often, if you do this a lot, you don't bother to use software to make clones. You get special hardware just to clone drives. And these can get, this is faster. By the way, if you're going to make an image drive, it is a best practice to clean everything off that drive first. So you can go to court and say there is nothing on this drive except data I copied from the target machine. And a lot of people still believe in this old-fashioned DoD 7-pass secure erase, where you write 7 times over the drive with random numbers. This is a persistent myth. This is not necessary. It has not been necessary for 20 years. There was a really, really old drive technology where 1 pass was not enough to erase all the data. That is long extinct. 1 pass of zeros erases all the data on a drive. You don't need to do 7 passes, but some people continue to do it. It's just a waste of time. It doesn't do any harm. But anyway, you do want to erase all the data on the drive before you collect forensic evidence. Otherwise, you will be confronted in court with the argument that the evidence you find didn't really come from the machine, and that's unprofessional. All right, so solid-state drives are what most people have. That's what I've got here. That's probably what you all have on your laptops. The old rotating hard drives take more power, and they're slower. So almost all portable devices now have solid-state devices, which are more expensive but faster. And those are not the same. They do remember when the power goes off, which is the main thing, but because you cannot write 512 block sectors to them. You can only write really big blocks of data to them. So to make them faster, you have to clean up the used sectors. And there's a background process called garbage collection that runs on most of them. So what happens is there's a trim process. The SSDs must erase data before they can write, whereas magnetic hard drives can write on top of an area where there is data. It will just automatically erase it. So they have a trim process, where when you delete a file, your operating system tells the SSD, I have deleted this file, you can now garbage collect it. And it tries to take all the used files and sweep them together to make a nice big block of empty space, and then it erases it in a big block. That's called garbage collection, and it only works if trim is functioning. And in my experience a few years ago when I did research on this, only about half of the devices really had trim working. So quite a few SSDs did in fact retain old files, and you can recover old files with forensic tools, but a good portion of them don't. If trim is working correctly, then most of the files that are deleted are erased within seconds by the background process, and you can't recover very much from deleted files, although there are small fragments that haven't been trimmed yet. But it's not like a hard drive where you'll find a lot of complete files just sitting on the hard drive that have been deleted but haven't been overwritten yet. Anyway,
Could you format the whole thing to get the copies correctly done?
well, this is a very good question. Remember, formatting does nothing on a magnetic drive or an SSD. Formatting does not clean the drive. What you have to do is write all over it with zeros. And you can do that with the command line clean all command in diskpart in Windows. But if you write zeros in every sector to clean a drive, that does not thoroughly clean the drive anymore. It used to, back when drives were smaller than 500 gigabytes. But when drives got bigger than 500 gigabytes, and all SSD drives of all sizes have a problem with bad sectors appearing, and so they have an invisible process that takes care of on the controller of replacing bad sectors with other extra sectors. So when you try to erase it, you can't get it all. Now you can get 99% of the data. So overwriting with zeros will get most of the data, and probably no useful data will be recovered. But if you want to go to court and say, I testify that the customer's data was really gone off this drive, you can't really say that, because there are some sectors you can't reach to erase anymore because they've been marked bad.
Is there software that like go to every sector?
You can't reach every sector anymore because
Is there software that go to every sector?
no, the problem is the controller built into the drive lies to the computer about the sectors. So if sector 10 goes bad, it silently replaces it with another sector. And now every time the computer tries to write to sector 10, the controller writes it somewhere else without telling the computer. So there's no program on the computer that can write, or the sector has any control of what physical sector you're writing to anymore. The only way you could do it is by trusting the firmware of the drive to erase it, or by hacking and altering the firmware of the drive, which can be done, but it's a serious reverse engineering task, not simple at all. There's no product you can buy that will do it. That's why people mechanically destroy drives when they throw them away. That's the only way to be sure that there was no data on there. Unless you do what the iPhone does and you encrypt the data right from the beginning. Then you delete the key, and now it's okay. Even if some stuff is left, it's encrypted. But this is a problem. There was a time 8 years ago when hard drives were smaller than 500 gigs and they were actually spinning mechanical platters, when they actually had a mapping of sectors and your computer actually had a one-to-one mapping of what sector you were reading and writing from, and then you could erase the whole drive, but not any modern drive. This is not commonly known for magnetic drives, but it's well known for SSDs. So anyway, then there's RAM. RAM is the chips on them that you hack to your computer that have a lot of memory you can use while the machine is running, but when you turn it off, it forgets within a few seconds. So this is why it's best to take a live image of a machine if you want to get the RAM image and find out things like what network connections it's making and what processes are running right now. And the tool to analyze RAM, the main tool used is volatility. You have to have a special tool that will parse RAM and reconstruct things from it. So you can read like Word documents and notepad files in memory and command prompt windows that have commands in it and things like that. Otherwise, you've just got a bunch of incomprehensible junk in there that is hard to analyze except for finding strings. Now, if you have a large amount of data, not what a normal user would have, but what a company would have, or especially a storage company like Dropbox or something, then they have RAID arrays. Because disk drives fail pretty often, and you don't want to have an outage when your disk drive fails, so you get an array of multiple drives, typically 5 or more, And there's multiple copies of the data on here. So if one of these drives fails, the others have all the data you need, and the light will change, and you pull that out and swap it with another drive, and it'll recreate all the data on there. So this way you can maintain availability even as the drives fail. Now, of course, there's a limit, and depending on how you configure the RAID, it might not be able to survive 2 of them failing at once, and so on, but this increases the availability of it. And that means that the data is in stripes across all these volumes. And so reconstructing data, taking a forensic image of all these volumes and reconstructing it is very difficult, very burdensome, and almost nobody ever bothers. If you have an array like that, you typically settle for just getting the active data from the running system, unless you really have to get it all, and then it's going to be a really big job to analyze all these images you're going to get. Now, there's removable storage devices. FireWire was an old one used by Apple a lot to connect external drives. Then it was replaced by Thunderbolt. Now I think everybody's moved to USB-C or USB 3 and so on. All these will have different connection rates, and they'll connect to external drives. And then there's flash drives. Flash drives have these memory that remembers without power, but they're kind of slow. So that's another way to store data. They've replaced floppies essentially these days. And by the way, as I mentioned before, all USB drives that are connected to a machine are stored in the registry. The Windows registry records every USB device you connected, so this is a nice case to look. The USB store key is where you look, and you can find all the devices that have been connected to this machine, and therefore all those devices probably also contain evidence of interest. If you're analyzing a machine, you probably want to analyze all the other devices that have been connected to it, storing files from it. So external hard drives, there are ones that are powered through the USB cable and one that have a separate power cord. And inside there is a SATA drive, and you can just clone the drive externally, or you can connect it through the USB port and clone it that way too. In general, these days, many drives are encrypted though. So if a system is running and a USB drive is connected, if you leave the system running, it has the key and you can read the active data on that USB. If you pull the plug and make an image, you're probably going to get an encrypted mess that you can't open anymore. So that's why live imaging is becoming more popular than static imaging, where you turn the machine off and image the hard drive, because more machines are encrypted all the time. And if it's encrypted, the static image is useless. The only thing that will help you is the live image with it logged in, so it decrypts the data. And then you've got various cards. There were some older ones called multimedia cards. The main one everybody uses now are SD cards. You use them in cameras and for all other kinds of storage conditions. The Macs used to have SD card readers built into them, but not the latest ones. Some people, I think bad for my sister, people that take a lot of photographs, that was really cool. You take the SD card out of your camera, put it right in your Mac, but now you'd have to get a USB peripheral for that. Anyway, you can store a lot of data on these SSDs. They're a lot like flash drives. And there's also compact flash cards, which again are just another version of essentially the same thing. And Sony has some kind of proprietary version of the same thing too. There are quite a few of these different ones, all do the same job essentially. XD picture cards. And by the way, if you read any drive of any kind, it is the best practice to use a write blocker, if you can, to make sure that you don't change any data while you're reading it. Live images don't make that possible, but that was the static. So it'd be nice to get a hardware to read something like a flash stick. Then you can take an image, making sure you're not changing anything on there. Then there's compact discs. I don't know how many people are still using these optical drives. I haven't used them in years, but anyway, CDs, DVDs, those are around there. You can store computer data on them. And of course, they tend to be forensically sound because they tend to be only writable once. So what's on there is permanent. There are ones that are rewritable. And anyway, the only thing about them is they store data and read data more slowly than magnetic hard drives or SSDs. But they're perfectly fine. And you read them with a laser by shining light and bouncing off little shiny spots on them is how it stores the data, instead of using magnetism the way hard drives do, or I think basically transistors, which is what SSDs do. All right, and then Blu-rays, of course, DVDs and Blu-rays are just higher capacities of the same thing, read with lasers and storing more and more data. And you might have these old floppy drives around, only in really old systems, and if you do, you're going to have to find some really old drives to read them. I did a fraud case for a religious ministry, and I was phoning a TV evangelist who had been ripping off people for like 8 years, and they gave me a stack of like 19 of these 8-inch floppies with a rubber band. That was the data. And it sat around for years because nobody wanted to bother. And I was the guy that figured out all that junk was and figured out how much money he'd ripped off from all those people so we could give it back. It was an interesting case in that regard. It was an interesting database job. I had like 5 years of Microsoft proprietary databases on 8-inch floppies. And I figured out how to deconvolute all that garbage and turn it into something modern that you could use to print checks.
And those are two different type of floppy disks?
Oh yeah, this is the newer kind. It had a plastic case. Before that, it had a floppy case, and then there was 3 generations of these. These are the 5¼ inch. Then there was the 8-inch, and then there was like the 10-inch, and more extinct. Yeah. Anyway, that's what I thought. It's funny. Most those, like Microsoft Word, has a picture of this to save your file, and most kids these days say, "What is that thing?" That doesn't mean save your file to them anymore. They've never seen this thing. And I say, yeah, it is. They should really change that icon, to something else. There was a time when this is what it looked like when you saved your file, but, not in a long time. What's that?
It's still used.
Oh, some people still use it, but not very many.
The 747, the airplane, they
Oh.
that would use it.
Oh, yes, 747. Oh, lots of things. Like I remember a few years ago, it came out that the metal detectors at airports that TSA is using, those things run on Windows 98 with a hard-coded password that can't be changed. It leaked out a few years ago. That's the problem. A lot of people build heavy infrastructure like airplane engines, and they expect it to last for 20 years. And of course, the computers are out of date within 5 years, and laughably out of date. And there's a disconnect there. The people that build heavy stuff like tractors and things, they don't think about upgrading the computer in just a few years. So they're always using and space missions, they're using appalling old-fashioned stuff, that's really out of date because anything you can't update frequently.
Because they need to qualification and then everything, all the steps to qualify for use.
That's true too. Yes, they have rules for qualification. But anyway, this is the huge problem actually. The infrastructure lasting for such a long period of time, the computing part of it doesn't last that long. Remember, you might even remember these crazy things, zip disks. They're thicker than floppies and hold more. I saw them throwing away a few of these at the start of the semester. Yeah, anyway, and then there's magnetic tapes and cartridges. Those are still around, used as backups. There's a bunch of them. They never seem to be standardized. And if you get one, you'll have to find a reader somewhere. That's why one thing forensic examiners sometimes do is connect to local hobbyists that have things like Amigas and old computers, because they're the only people that have the equipment and the know-how to read off of these old devices. And like I say, there's ways to get data that is imperfect. Like I mentioned before, if you have a cell phone and you can't connect it to anything electronically, you can just page through the messages and take pictures. And then you're getting some of the data. It is not a perfect process, but you are finding evidence, and it is on the device, and it can hold up in court as long as you explain what you did. Often you have to switch to imperfect processes. The command to write zeros to memory, let me put this up here. I see some questions. Let me bring up a text. Okay. If you want to erase a hard drive in Windows, what you do is open a command prompt, and you do disk part, list disk, then select disk. Figure out which disk you want to erase and don't get the wrong one, or you'll be sorry. Then select the disk and then clean all. It will now take a couple of hours, and it will write zeros over the whole volume, and it's gone forever. This is how you clean a machine. Now, you can also download a product. There's a free one called Steganography, and I think Eraser. Eraser is probably the easiest one. But most people probably rather use Eraser. Yeah, here's a Eraser. Here's a program that will just securely erase files from disks and also disks. This is probably a more practical thing for most people, is to download an app and use it. I'll put this in the chat. But you don't really need an app. It's built into Windows, the ability to do this, but you do have to be careful. You can erase the wrong volume, and then that's your own operating system with your documents and stuff, and you're going to have a bad day. Unless you're backing stuff up, which you should be, but most people only start backing things up after they lose their stuff a few times. I lost my thesis 7 times when I got getting my PhD, and then I learned to back things up, Anyway, so is it true if you slide the metal piece over it, it deletes the data? No, on floppies, no. You can delete data on magnetic drives with a powerful magnet, but it takes a very powerful magnet. You can't do anything. You can't just move an ordinary metal piece over it to delete it. And Ross Perot funded Steve Jobs' magnetic drive-driven computers. Oh, yeah, he probably did. Yeah, in the early days. All right, I see some comments. Good. And I think that's it for this. So let's take a look at the Cahoots. And then I'll talk about projects. All right, that's it, mod 3. All right, give it a few more seconds. Ah, good, %20. That's good to see. People are paying attention to URL encoding. I better wait a bit. People are still coming in. I'll give it a few more seconds. All right. All right, so what's the most common connector for hard drives? Yeah, it's mostly SATA these days. I think eSATA is even faster, not as common. These are both pretty out of date now. SATA is mostly what you have, serial ATA. Okay, what process makes a file containing all the data on a drive? Okay, that image is what it's called. A backup is just a copy of the active data, which is what normal people want, but forensic examiners want all the data, including the deleted data, and that you get with an image copy. That's why they call it imaging. Cloning makes an exactly identical drive the same size that you could boot from, and that's not usually what you want. You usually want a file that you can copy and move from system to system. That's an image. All right, what storage device may erase old data automatically through garbage collection? All right, that's the SSDs. RAM doesn't have any garbage collection, but as soon as you turn the power off, it just forgets anyway. But the SSDs have a garbage collection process that runs in the background, erasing old data. All right, which storage device is read with a laser? All right, and that's DVDs, the optical drives. All right, let me get the winners. JD, I hope those are real initials. My grader can probably figure out who you are. And Ronan. stop the recording.